As we travel along Highway 6, we come to Parachute, Colorado. As we get to Battlement Mesa Road, we turn right. We take Battlement Mesa Road until we get to County Road 301. We turn left on 301 and travel east until we come to County Road 310. When you get to the Rulison Road, you turn right. We travel south on the Rulison Road until we get to the Rulison site marker on the left side of the road. Welcome to the Rulison site, where a 40-kiloton nuclear device was detonated in 1973. As you can see, there is something there on the site, so check with local government.
Some 6 miles from this tiny western Colorado town, a unique experiment will be conducted by a joint industry and government team. A nuclear explosive equal to 40,000 tons of TNT will be used to shake loose a great natural gas reserve locked tightly in a formation called the Mesa Verde. The experiment is called Project Rulison, part of the Atomic Energy Commission's Plowshare program to develop peaceful applications for nuclear explosives. Its purpose is to gather data on the feasibility of using nuclear stimulation techniques to develop commercially a natural gas-bearing field in a low permeability formation. The experiment will be conducted on Battlement Mesa under lands leased by the Austral Oil Company of Houston, Texas. A portion of these lands is publicly owned. Part of the Mesa Verde Formation is visible here near Grand Junction, Colorado, about 40 air miles from surface ground zero. This is what the formation looks like at ground zero under the pressure of some 8,500 feet of Battlement Mesa formations above it. The gray sections are Mesa Verde sandstone, and the black portions are shale, which sandwich the sandstone and thus entrap the natural gas. The conventional way to release such entrapped gas is to break up the formation by shattering it with nitroglycerin or to open fractures with liquid under pressure. The Atomic Energy Commission believes a nuclear explosive will prove far cheaper and a great deal more efficient. Austral Oil Company is betting on it. The project was proposed by Austral and the nuclear engineering consulting firm of CER Geonuclear Corporation of Las Vegas, Nevada. The cost of the program is estimated at $6.5 million, of which 10% is borne by the government and the rest by Austral in a carefully calculated investment. At stake is an estimated 110 billion cubic feet of gas per section in place at the experiment site. If the rulison test shows this gas can be extracted at a profit, it will open the way to recovery of vast gas resources not now accessible, 8 trillion cubic feet in the Mesa Verde Formation alone. In addition to the Atomic Energy Commission, the government is also represented by the Bureau of Mines of the Department of the Interior, which is concerned with development and use of all domestic natural resources, and the AEC's Los Alamos Scientific Laboratory of the University of California, which developed the world's first atomic and thermonuclear explosives. This is the control point from which the nuclear explosive will be fired. Surface ground zero is about 3 miles south of here in an area forested mostly by aspen. A pre-shot exploratory test well was drilled only a short distance from surface ground zero to evaluate the normal production of the gas formation at ground zero before nuclear stimulation. Another major purpose in drilling this pre-shot well was to determine the nature of the underground water table, if any, in the area. The conclusion is that there is no flow of water or supply that could be harmfully disturbed by the detonation. This is a cross-section of the rulison field. Detonation point is about 8,500 feet beneath surface ground zero. This is how the device is expected to stimulate gas production in the rulison field. The energy released by the nuclear explosion will melt and vaporize nearby rock and will fracture the rock beyond to a diameter of about 740 feet. A spherical cavity of about 160 feet in diameter will be created in about 1/10 of a second, or in about the time the shock wave rebounds from the surface. As the cavity cools, the vaporized and melted rock will collect in a puddle at the bottom, and most of the radioactivity will be entrapped here as it solidifies. Sometime after the explosion, the roof of the cavity will collapse progressively upward, forming a chimney of broken rock to a height of about 370 feet above the point of detonation. Government experts say the fractures beyond the cavity area are expected to provide flow channels for some of the gas trapped in the surrounding rock. The chimney will act as a chamber where the gas will collect, to be drawn off through a well drilled back into the chimney. The rulison test should prove the Plowshare contention that there are two good reasons to favor nuclear over conventional explosives: economy and efficiency. In this small package is the energy equivalent of 40,000 tons of TNT. Nitroglycerin might possibly be able to do the same job as the nuclear explosive is expected to do, but 19 million quarts would be required. That would occupy a volume of 100,000 times the size of this nuclear explosive. The cost would be prohibitive, perhaps 10 times the amount of money spent by Austral Oil Company in this experiment, and the safety problems nerve-shattering. For rulison, the Los Alamos Scientific Laboratory modified this nuclear device from a system tested in Nevada. Backfilling at the 8,500-foot emplacement hole is a well-developed technique perfected at the AEC's Nevada test site. By alternating layers of coarse and fine sands, underground containment of gases developed during the nuclear explosion can be assured. The device will be set off 2.6 miles from surface ground zero. The rulison control room is comparatively simple because the performance of the explosive is known and therefore few measurements are required. When the event occurs, the countdown will sound just like this one.
9, 8, 7, 6, 5, 4, 3, 2, 1, fire!